Okay, in this video we're going to look at solving trig identities or proving trig identities using double angle formula as well. So the first example says prove tan x plus cot x is identically equal to 2 cosec 2x. So again, you can do this using either side, but I like to pick the side which has more things going on. So my left hand side's got two terms, so I'm going to use it. So my left hand side was tan x plus cot x. I'm going to write this one as tan x plus 1 over tan x. And all I'm going to do here is take a common denominator of tan. So that would be 1, and then the left part of it is going to be tan squared. So tan squared plus 1 all over tan x. We'll go up here with this. Okay, I've got tan squared plus 1. I'm just going to write down my basic trig identity, which was sine squared x plus cos squared x is equal to 1. If I divide through by cos squared, see what I'll get. I'll get tan squared x plus 1 is equal to sec squared x. So here, this really becomes sec squared x over tan x. Okay, still haven't got there. Haven't got it in the form that I'd want. So I'm going to rewrite my this is really my sec, which is 1 over cos squared x over my tan, which is the same as sine x over cos x, and then we'll see what we can do from this. So that is the same as 1 over cos squared x times, so when you're dividing by a fraction, changes divide sign to a times and turn the thing upside down, turn the dividing fraction upside down. So that's what you've got here, and if you did that out, what you're going to get is the cos, one of the cos's will cancel, so you're going to have 1 over, and I'll write it as sine x upon cos x on the denominator. Now this is the same, now this is where you have to play around with it a wee bit. Here, this is almost the same as sine of 2x, but not quite. So I'm going to try and make it, how I can make that be the same as sine of 2x is if I doubled it. So it becomes 2 sine x cos x. So because I've doubled the denominator, I have to also double the numerator. So that's what I'm going to have. So really this is the same as 2 over sine 2x, which is the same as 2 cosec x. Okay, so I've worked all around the page. I've worked across the page. It's horribly set out, but you can see what I've done. Okay, again, I'm going to work with the left-hand side because there's an awful lot more going on with the left-hand side in this particular example. So I'm going to change my left-hand side and I'm going to write it as 2 sine theta cos theta. That's how I'm going to change my sine to theta. Now, this is this comes with experience, really. So seeing this here type of question, you've got 3 ways, remember, of writing cos 2 theta. Sorry, you could write it as cos squared theta minus sine squared theta. You could write it as 2 cos squared theta minus 1, or you could write it as 1 minus 2 sine squared theta. Now think about what tan looks like. So tan is sine over cos, so it has one term in the bottom line, and it definitely does not have a 1 term. So I'm going to pick the version of this such that it will eliminate 1 from the bottom line, the denominator. So I've still got my 1 at the minute, and I'm going to write it as 2. My cos 2 theta, I'm going to write it as 2 cos squared minus 1. So you can see what happens. This 1 and this new minus 1 will cancel each other out. So it leaves you with just 2 sine theta cos theta over 2 cos squared theta. And then if you do that out, the 2's will cancel and the cos on the top will cancel with all the cos's at the bottom. So it'll leave you sine over cos, which is the same as your tan, which is your right hand side. Happy days, you've done it. Okay, again, there's definitely more you can do with the left hand side. I'm going to write this in terms of sine and cos. So first of all, I'm going to write it as sine of 2x, 1 over sine of 2x plus, and cot, remember, is cos 2x over sine 2x. And again, I can take a common denominator here. So common denominator is going to be 1 plus cos of 2x, and the bottom line is going to be sine of 2x. So common denominator, sorry, was sine 2x. Top line then is 1 plus cos 2x. Right, nothing else we can do here. Have a look at where we're trying to get to. We have to just rewrite this thing. So I'm going to rewrite it. Bottom line, there's no thinking involved here. You've no options. But the top line, again, we want to get rid of this 1 here. It has to go. So I'm going to have to write my cos 2x. So there's my 1 still, but I have to write my cos 2x as 2 cos squared x minus 1. And that will become, oh, sorry. And then what we have is very similar to the previous example, really. That's just going to be 2 cos squared x over 2 sine x cos x. And we can just cancel out the 2's. And we're going to be left, cancel out one of the cos's, and you're going to be left with cos x over sine x, which is equal to cot x, which is equal to your right hand side. So very similar to the previous example, really. Okay, in this example, we've got to prove that sine 3x is identically equal to 3 sine x minus 4 sine cubed. And in this one, I'm going to look at my left-hand side, which is unusual. It goes against everything I've been saying. The previous ones I've been saying I've been working with the side there's more going on. It doesn't look like there's a lot going on. On my left-hand side, it's just sine 3x. But we could write sine 3x as sine of brackets x plus 2x, which is then equal to sine of x cos of 2x plus cos of x sine of 2x. And what we're going to do then is to expand this thing here. So notice, look again, look where we're going to. Our sine is completely in terms, or right hand side, sorry, is complete in terms of sine. So I'm going to write my cos 2x in the version that is just to do with sine. You could get there, you would get there eventually if you do it the other way, but it just makes it much more efficient if you do it this way. So I'm going to go straight to the sine version, which was 1 minus 2 sine squared x. I've still got this cos term, which hopefully we'll get rid of soon. And sine 2x, there's only one way to rewrite it, and it's sine x cos x. So a bit of tidying up to do. Multiply out the brackets where you can. That's going to be sine x minus 2 sine cubed x. And then plus 2 sine x, and cos times cos is cos squared x. Okay, again, let's just look at where we are. We've got a cos squared term. They have no cos squared terms. It's all sine in there, so we want to change this cos squared to be 1 minus sine squared. So what we have so far is 2 sine x 1 minus sine squared x. Multiply out, tidy up, and see where we get. So we're going to have sine x minus 2 sine cubed x, plus that's going to be 2 sine x when you multiply the bracket minus 2 sine cubed x. And then tidy up, what you're going to be left with, you've got a sine x plus another 2 sine x, that's 3 sine x, and then minus 4 sine cubed x, which happy days is equal to our right hand side, and that's good. Okay, there's a wee note here. It just says you should be able to derive the equivalent results for tan 3x and cos 3x. So it's important that we're able to do that. Okay, after you've done all that, folks, you're now ready to do topic 5. It is a trig B section, and exercise 2, questions 9 and 10.